Okay, so this is from our red book. It's page 142, and it is just an example of using the square root method for an equilibrium calculation. So in terms of our blurb, we have to calculate our equilibrium concentration. We have 5 moles of HI, and that's decomposing in 12 litres. And what's different now compared to our straightforward method is we actually have a Kc value. And when you see that Kc value, that is your hint that you're going to be using your square root method or you're going to be using your quadratic formula. Okay, so that kind of will give you an indicator of where you're going to go. So the first thing we always do is we just write our Kc equation. So again, look, products over reactants, everything goes in square brackets. You use the ratio to determine your powers. So seeing as hydrogen and iodine are 1:1, they get no power. Hi is, there's 2 of them, so that's going to be to the power of 2. And we now know that this is equal to 0.0185. So we rewrite our equation using the reactants and the products as our headers. We're going to have an initial line. We're going to have an equilibrium line when we're done. We use the ratio and we just put it in as a value of x. So for my reactants, they're going to change by, in this case, 2x. My products are going to increase by x when we have them. The information that we have is we have 5 moles in 12 litres. At this point, I always like to do that division because I sometimes feel I'm going to forget at the end. So we've now taken care of this because we need to use numbers in our equation that are in moles per litre. We always say our reactants, our products are always 0 initially. Here, straight away, you will notice that the first thing I'll say is my equilibrium line will be 0.42 take away 2x. My products will increase by the value of x and the value of x. And there's nothing in the question now that can allow me to solve. In a straightforward, we'd get the concentration of our products. There's nothing there, so I now have to use this equilibrium line and plug it into my Kc equation. So Kc in this case is going to be equal to x by x. And as I've said in previous videos, I want you to recognize that this is x squared. We're now putting 0.42 minus 2x. And again, this is going to be squared. And we now know that that's equal to 0.0185. So the giveaway here that I can use my square root equation is the fact that both of these things in the Kc equation are to the power of 2. I can now square root both sides, and when I do this, I end up with x over 0.42 minus 2x, which is now equal to 0.136. And we're now just going to move things backwards and forwards to get them set up for solving x. So the first thing I'm going to deal with is this, and to get this to the other side, I have to multiply both sides by it. So for 2 minus 2x. So when I do that, I'm going to be left with x is equal to 0.05712 minus 0.272x. The next thing that I'm going to do is I want to put this all the way over to the other side. So to do that, I add 0.272x to both sides. Okay, so I should have said earlier, when you put these together, they obviously cancel out. In this case, these guys are going to cancel out. So when I rewrite, I now will have 1.272x is going to be equal to 0.05712. I want to move this now to the other side, and to do that I divide both sides by it. 1.272, and that should leave me with x is equal to 0.045. We have to check, have I answered the question asked? Okay, because sometimes we may not. So we go back up to my question, and it just asked me, we had it up here, calculate my equilibrium concentration of hydrogen. My equilibrium concentration of hydrogen is the value of x per my table. So this is my final answer. We are now correct.